Welcome again. I hope you all are good. And today we are gonna discuss about this DVQA paper. DVQA is Understanding Data Visualization via Question Answering. So this paper is published by Kafle et al. Kaushal Kafle et al. In CVPR 2018. So this paper is highly motivated with visual question answering task that focus on common sense plus reasoning task, that is task driven. And as we can see in this right hand side image, the question is what color are her eyes. So this is a natural language questions been asking from this image. So, so this is why if we can do it for natural images, natural scene images, why don't we do it for chart images or other images? So, uh, this paper is highly motivated. So DVK paper is highly motivated with previous paper, visual question answering. Uh, so it also it performed all the baselines on DVQA data set, but that baselines, uh, which is yes, IMG question plus IMG, SAN VQA, all the baselines are incapable of answering many of the questions in proposed data set DVQA. So, DBQA require processing word and answers that are unique to a particular bar chart. So that is why this paper proposed two DVQA systems, Mom and Sandy. This is capable of handling a word that are unique to a particular bar images. So let's look at the first some base sort of VK baselines from previous papers. Then we will see two method that is proposed in this paper. So baseline says uh, it have five baselines in sort of VQA that is incapable of answering many of the questions. So first model is yes model. So this model answer yes for all questions, which is most common answer in the DVQA by just a small margin over some no. So then comes to IMG model. So this is a question blind model in which images are encoded using ResNet using the output of its final convolution layer after cooling, and then answer is predicted from them by using MLP layer or with one hidden layer that has 1024 unit as a softmax output layer. So in a similar way, another model is question. Question is image blind model. So why this is called a question blind model, and this is calling as image blind model, because this question blind model in which we don't have to give any question, we just have to give image, and then image, then answer will be only from image and not from text. So that's why it is a question blind model. And then another model is a question model, that is image blind model. Then we don't need to give the image for output of answer, but we only have to give the question, and it will, based on the question, it will give answer. uh, so for this also, for question model also and image blind model, it uses a LSTM encoder to encode the question. So on all the model, if image are if we are giving image, then it is using a ResNet model. If question is giving, then it is using a LSTM model. So then at the final layer, this MLP is using with one hidden layer for of 1024 unit with a softmax output layer for everything. So next model is this image plus questions, in which image answer is generated from image as well as from question. So this is a combination of question and image model. Yes. So it concatenate, because this is a combination of question and image model, so it concatenate the LSTM and CNN embedding, and then feed those embedding to an MLP with 1024 unit hidden layer. and also with a softmax output layer. Then it comes to SAN-VQA model. So SAN-VQA model demonstrated that of upgrading the original SAN images features, then couple of changes can produce the state of the art result. So all these baselines have performed giving some up to some point, some accuracy, but still for a out of uh, for a kind of unique word that is unique to answer that are unique to a particular bar chart image, then this fail. This all the models fail. So for that, this paper proposed their own model, that is multi-output model. In this multi-output model, it uses two subnet, or uh, because it uses a dual network architecture, that's why it uses a two subnet. So first subnet is for generic answers, and second subnet is for charter specific answer. If a question is simple and it is using just it can answer can given only from image, and it uses reverse model, that subnet 1 is based on the SAN attention network, as in previous pipeline, previous baseline. And here another model is OCR subnetwork, and that is for chart specific type, and it tries to predict the bounding box here. So tries to predict bounding box containing the correct label, and then applies a character label decoder to that region. Also, the bounding box predictor is trained as a regression task using MSE laws. So here you can say that image patch is extracted from the region which is resized to 128 into 128, then a small 3-layer CNN is applied to it, and there is some number of stacked n-step spatial attention mechanisms used to encode the relevant feature for each of the n possible character in the image patches. So also here n features are encoded using a bi-directional this GRU. That n feature is generated from this. So this n feature is encoded using bidirectional GRU to capture the character label correlation found in naturally occurring word. So the GRU encoder followed by a classification layer that predict character sequence. So it uses CTC laws for producing the character sequence, and MSE laws for this bounding box. So so mom has some limitation, that it has no explicit ability to visually read bar chart and bar chart text. So its LSTM question encoding cannot handle chart specific word. So that's so that uh, they uh, say that uh, what we say, um, yeah, so they present another model, Sandy with a dynamic encoding model. So that dynamic encoding model is a dynamic local dictionary for a chart specific word. This dictionary is used for encoding word as well as answer. It accesses OCR system that gives the position and string for all text areas in a bar chart. So this model work well for DVQA dataset, because DVQA dataset is synthetic, but it fails when for out of vocabulary question answer. So also the dynamic encoding is inferred based on the position of previous detected word. So if we use the previous detected word, means if any error in the OCR system in detecting single word will propagate throughout the chain and render the encoding for the whole image become useless. So performance also drop for real OCR system, and if we remove the cascade reliance on correctness of each OCR result, it can help to improve performance for imperfect real world OCR system. So these were a lot of drawback. Also, this dataset is somewhat synthetic. So when it comes to real more realistic images, real world images, this approach is not giving too much of accuracy. So for this we can see some of the accuracies of all the baselines and for Sandy models. So this is overall result for model trained and tested on DVK dataset. So well this is overall performance is 11.78, that is very low, because it is giving yes for every question aspect of whatever we are asking, it is giving yes. And another model is image model, question blind model. So this is um, just all image we are giving and we are asking question from that, we are not giving question for that. So that is image blind, question blind. And this is so performance, we can, you will see this performance too low, because it's not up to, it's like not 50%, at least it's too less image performance. Also for test novel performance exactly as same with a minor variations. So proposed method have accuracy of at least better than before. Mom have 40.87 89, and mom plus have this 45.03. Mom has a variation. Also Sandy have two versions, Sandy Oracle and Sandy OCR. So Sandy Oracle is giving better performance of 56.48 on test familiar, and also for test novel it is giving 56.62. Sunday OCR is giving 45.77, and for test novel it is giving 45.81. Also, for a chart specific word question and answer, state of the week algorithm struggle with both. So here you can say if we have chart specific questions, chart specific answer, then overall performance is also very less here. And also for test novel our overall performance is less, it's like similar to the, somewhat similar to that. So this performance is low, but it's nice that this paper is uh, trying to solve the paper task of question answering over chart and images. So this is a huge contribution of this paper. And also did first uh, data set that used for this kind of question answering task, large scale data set. So yeah, this paper is too much good but have some limitation. Thank you.